Hey students, it's Mrs. Owens here. Sorry I couldn't be here today. You do have a sub and I will be here next time, but I wanted to go over some of the things that you are assigned to do today. So hopefully you had a couple minutes to look at the starter for today. If you have not, we can go over that. Um, we also will be doing some notes today and then an assignment called Evidence of Climate Change. So let's go ahead and take a look at your starter. So just a reminder, this unit is all about the cycling of matter and the flow of energy. So last time we were together, we talked about how energy flows from one form to the next. It can't be destroyed or created, but it just changes forms, right? So for example, we said that plants get their energy from the sun. So they take that light energy and they convert it into chemical energy, or they store that energy in the bonds in the sugar that they make. So anyway, energy can just be passed from one form to the next. So let's take a look at question 1 on your starter. It says, how much energy is passed from one trophic level to the next? So we start down here with our primary producers. These guys get their energy from the sun. And then as organisms eat this energy or they consume it, energy is passed from the plant to that animal. Now, only about 10% of the energy is passed in this process. Most of the energy that these plants use is given off in the form of heat and it's lost. We can't use it anymore. So only 10% is available to the next level. And that doesn't mean organism, right? So it's not like this bug here only gets 10% of what the plant has to offer. It's just saying in general, all the organisms on that level are only able to get about 10% of the energy available from the plants. Okay, question 2, it says, unlike the one-way blank of energy, this is going to be flow, so energy flows in one direction. Matter is recycled within and between ecosystems. So matter can be recycled, energy just flows, it's one direction. Okay, question 3, where do plants get energy to grow? Hopefully you know they get energy from light. It doesn't necessarily have to be sunlight, but the sun is a great source of light. And that's really what powers our whole earth. Okay, question 4, where do animals get energy to grow? We do not get energy from light. We do not photosynthesize. I wish we could because I love to photosynthesize out in the sun. I like to suntan, but that is not where I get my energy. I actually get my energy from food, right? So those molecules store energy in the bonds. When those bonds are broken, then our body's able to use that energy. So hopefully that was a good review of what we talked about last time. You can go ahead and submit the starter. I'm going to give you guys a couple seconds to pull out your note packet. We are on unit 3 of our notes. They look like this, and it's actually an orange packet. So if you were not here last time, go ahead and let the sub know. There are some orange packets on the front table. So you can go grab one of those or have the sub bring one to you. For everyone else, you can pull those out. Just a reminder, our test date for B-Day is scheduled next week on Wednesday, October 18th. This is a really short unit, so make sure to jot that down. October 18th is your test date. And this test is not going on this quarter's grade, it's going on quarter 2's grade. That being said, all of the assignments for this quarter, including those that you are doing today, will go on quarter 1's grade. So make sure you're staying up to date. Make sure you're not slacking off just because there's a sub today. Okay, so we've got our note packet out. So far, we've done pages 2, 3, and 4. We're going to take a look at page 5 here, and then we're actually going to do 6 and 7. There's a little activity I'm going to have you do to mimic the carbon cycle. So let me pull up page 5. It looks like this here. Put it in slideshow mode so we can see it a little bit better. I'm just going to go ahead and read the top section so you can follow along with me. I'll make it a little bigger here. It says cycling of matter. Matter moves through living things differently than the way in which energy moves. Earth doesn't receive a significant steady supply of new matter from space. Unlike the one-way flow of energy, matter is recycled within and between ecosystems. Elements pass from one organism to another and among parts of the biosphere through closed loops. So today we're specifically going to talk about the carbon cycle, but it is important to know that nitrogen has a cycle, water has a cycle. You probably talked about the water cycle before in other classes. Carbon is going to be the focus of this unit. So carbon is a major component of all organic compounds. Organic means it has carbon in it, right? Including carbohydrates, lipids, proteins, and nucleic acids. Hopefully that's a good review of our different macromolecules that we learned last time. In fact, carbon is such a key ingredient of living tissues and ecosystems that life on Earth is often described as carbon-based life. Carbon in the form of calcium carbonate, CaCO3, is an important component of many kinds of animal skeletons and is also found in several kinds of rocks. Carbon and oxygen form carbon dioxide gas, CO2, which is an important component of the atmosphere and is dissolved in oceans. So we'll get a little bit of practice with that today. First, I want to look at this diagram here. So we're just going to go through all the different processes that are found in this diagram. I already have our first process here. We're going to call this extraction. So when we take fossils out of the ground that have carbon in them and essentially pull it out in the form of oil, coal, or gas, we're going to call that extraction. So this is the process that we're looking at here. You can go ahead and jot that in on your notes. So first we extract fuels out of the ground. Our next one is going to be combustion. So generally we use those oils, or we use that carbon and that energy by burning it. That will be like in the engine in our car, or whether we burn like coal for energy. So that's going to be combustion there, our second one. We have what we call pollution. So when carbon dioxide is burnt, it's given off into the atmosphere in the form of CO2. Sometimes there's other molecules too that have carbon in them, like carbon monoxide, which has one oxygen, but that's going to be pollution there. Another thing that can emit carbon dioxide into the atmosphere is what we call respiration. So respiration is when organisms, living things like animals or plants, when they breathe out carbon dioxide. So everyone take a breath in. You're breathing all that stuff in the air, right? There's nitrogen, oxygen, carbon dioxide. You're breathing it all in, but your body takes the oxygen that you breathe in and it uses it to help break down the food that we eat. And in the process, you breathe out carbon dioxide. So that's what we call respiration, respiring. Okay, next one here is consumption. So if a plant is eaten by an animal, all that carbon that's stored in the plant is obviously consumed. This is a consumer here, the animal. Animals eat other things, and so we are what we call consumers. If you're a primary consumer, you just eat plants, but if you're like a secondary or tertiary consumer, you're going to also eat animals. So that's consumption there. Right here we have decomposition. When animals and plants die, they are broken down by usually fungi we think of as decomposers, but also bacteria are huge decomposers. So in our diagram here, we've got some bacteria that are working to break down these organisms. So we got decomposition. These organisms are broken down and they return to the soil. Sometimes organisms can be preserved, and we call that fossilization. So obviously dinosaur bones can be fossilized, but a lot of the oil and gas that we think of actually come from plant material that's fossilized and turned into coal. So fossilization is going to be one there. Over here, we've got the ocean. So carbon dioxide can actually be dissolved into the ocean, and then animals will use that to create their skeletons. So a lot of like arthropods will use it to create their shells. And then coral also uses it to make their skeleton out of or to create calcium carbonate. When those organisms die, we call it sedimentation. That word is very similar to a geological term, sedimentary. Hopefully, you're familiar with sedimentary rocks. Those rocks form by layers and layers of sand and rock being compressed upon each other. And a lot of ocean animals are actually contributing to sedimentation. So, for example, corals form this hard surface. Their skeleton, which is calcium carbonate, that is broken down usually into sand, and then that sand is what's compressed. So a lot of like limestone rock is sedimentary rock, and it actually comes from living things. So it comes from animals like coral and arthropods that have shells. So we got limestone and shells over here from sedimentation. Photosynthesis here is when plants take carbon dioxide from the atmosphere and they use it to make sugar. That process requires light, but the whole goal is that plants are taking carbon dioxide from the atmosphere and they're producing sugar. You may notice that our plants take carbon dioxide in by photosynthesizing, but they also give off carbon dioxide through respiration. So plants actually do both, but they produce more oxygen than they give off carbon dioxide. So yeah, plants are really important. And for the most part, we generally think of plants as giving off oxygen rather than carbon dioxide, but they can do both. Okay, last one here is, I think there it is, dissolved in water. So carbon dioxide's in the atmosphere. We know that we're giving off pollution. We're breathing out carbon dioxide. Plants are breathing out carbon dioxide. And that carbon dioxide that's in the atmosphere can actually get dissolved into the ocean. So as waves crash up, the air is forming bubbles in the water, and that can dissolve into the water. So when carbon dioxide dissolves into water, we call it carbonic acid. And that carbonic acid is available for other creatures to use. So algae that photosynthesize in the water, they have to use carbon to make sugar. So they're going to use that carbonic acid. And then all those other animals that we were talking about that make shells, they use that carbonic acid in the water to form their shells. So essentially, it's just dissolved carbon dioxide. So that is our diagram here. We've got all of our different reservoirs. So animals, plants, ocean, stone. These are what we call reservoirs because it's places that are storing carbon. The atmosphere is even a reservoir. And then when carbon transfers from one reservoir to another, such as a plant being eaten by an animal, we call that a process. So all these things that you wrote in your little boxes here, these are processes. Okay, that is good to know for our game. So we've got page 5 filled out in our notes. Page 5. I'm going to have you go to page 6. We're going to do the carbon cycle game, and I'll help get you started on it, and you can use some time in class here to fill this out. So you're going to go to Canvas, so hopefully your computer's out. And when you go to today's date here and you click on Notes, let me open that up in another tab. You can see there's a bunch of information here, but what I'm going to have you do is click on the Answer tab. Once you go to Answers, you're going to click on pages 5 through 7, and it's going to pull up a new page for you. And it looks like this. So we've got the answers posted here. If you missed anything, you can fill those out for page 5. This is what you're going to do for page 6, the carbon cycle game. You have to have a dice to play this game. I don't have physical dice, but we can use this random dice roller. I'm going to click this link here, and you can just roll it as many times as you need. So I rolled my dice and I got a 6. In this game, you are going to move from reservoir to reservoir, and you're going to pretend to be a carbon atom. So it should be hopefully kind of fun, and it helps you understand how carbon moves. So I'm going to scroll through my different reservoirs here. If you get a number 1, you'll start in the atmosphere. If you roll a number 2, you'll start with plants. Number 3, you'll start with animals. 4 soil, 5 ocean, and 6 fossil fuels. So I rolled a number 6. I'll put fossil fuels in. And on my notes, or on your notes, what you'll do is you'll write your initial location right here. So I got fossil fuels, so I'm going to write in fossil fuels there. I'm going to roll my dice again once I get there. Let me pull that up. So I click number 6. I'll go to the next button here. And so once you get there, it gives you all these different options. Again, I'm going to roll my dice. And looks like I got a 1 this time. So I'll go back to this page and I'll look at number 1. It says it takes millions of years to form fossil fuels from dead plants and animals. Destination is stay in fossil fuels. Oh man, okay. Sometimes carbon just stays in one place for a long time. So my fossil fuels is going to be my new location because I actually didn't move. And what's my process? I'll just say stayed in the same place. This is not always what you're going to get. A lot of time you are going to move around, but that's important to know that sometimes carbon dioxide in the atmosphere just stays in the atmosphere for millions of years. Sometimes fossil fuels just stay in the ground for millions of years. Okay, so that's my round 1. Then for round 2, you're going to take your new location in round 1 and put it as your initial location for round 2. So we're starting over here. We got fossil fuels. I'm going to roll my dice again. We'll see what I get here. Okay, I got a 2. So I'll hit next because I stay in fossil fuels. Okay, so I'm still at fossil fuels. I got a 2 this time. It says humans have pumped the fuel that you are a part of out of the ground and have used it to power their cars. So this is an example of pollution, right? Carbon dioxide is combusted and given off into the atmosphere. So we'll say my new destination here is atmosphere, since I was used by a car. And what's my process? You can give either here. I know in our diagram, let me go back to our notes here, page 5. In our diagram, we said either pollution or combustion. So I'll just say combustion for this one, wherever it went. Let me X out these. I've got too many. Okay. So we'll say combustion for this one. Oh, spelled that wrong. Okay, combustion. So then again, I'm going to start line 3 with atmosphere, and you'll just go on until you fill out the entire diagram there. So I would hit next, and these are my options here for the atmosphere. Okay, hopefully that makes sense. You are just showing how you are moving from one place to the next as a little tiny carbon atom. When you are done filling out this entire diagram here, you're going to go to page 7, and you're actually going to model your game that you did on page 6. So, for example, I would start out drawing some fossil fuels in the ground. Maybe I'd draw like a little dinosaur or a leaf in the soil. And then I would draw an arrow up to the atmosphere and show that I was combusted. Maybe I would draw it to a car first and then up to the atmosphere. But essentially, you're just going to model your game here in a cycle. So show me how things flow from one molecule to the next using your carbon atoms. Okay, that will be it for your notes. So make sure to do pages 6 and 7. And then for the rest of class, let me go back to our agenda here. You'll be done with your notes. You have one more assignment called Evidence of Climate Change. And I'll just show you that real quick so everyone's up to speed. This will be a Google Doc that you're going to complete. And there are some links that you have to use. So make sure to click the links there, like number 1 asks you about this website here, so you could click that. Number 2 is going to ask you to read this graph. Same with number 3 and number 4. So you'll answer all those questions. And then at the very end here, we've got several different evidences of global warming. So melting of glaciers and ice caps, that's one example. And I've got a nice picture here about how our glaciers are melting. Ocean acidification. So remember, carbon dioxide actually dissolves into the water, and that's making it more acidic and increasing the temperatures of our ocean, which leads kind of to climate change here. So the thing that's kind of interesting about having more carbon dioxide in the atmosphere is, in general, it makes the atmosphere more warm. But because the atmosphere is more warm, we're seeing more extremes in our climates. So, for example, we see more extreme droughts. At the same time, we also see more extreme hurricanes. So, we have more flooding. Here's an example down here, extreme flooding. And we saw that just in New York City recently, right? New York City was flooding because of this hurricane that hit. At the same time, we've seen extreme winter weather. Think of this last winter. We had like record breaking snow, right? This is the most snow we've seen in a really, really long time. And then extreme heat waves, which is leading to extreme fires. So the big takeaway with climate change is like, yeah, our atmosphere is warmer, but because our atmosphere is warmer, we're just seeing more natural disasters, right? More extremes. So for number 7, you're going to pick one evidence of global warming. So either climate change, ocean acidification, or melting of glaciers and ice cap. And you're just going to write a paragraph to summarize what you've learned in those different sections. So hopefully that's self-explanatory. Again, please work during this class period. And if you have any questions, I left an answer key with our sub who can help you out. But yes, thank you for being good students, and I will see you next time in class.